Hello folks, well the parts have come for this DNT base station, so I thought we'd do it in this workshop instead of the other one, because I've got a Binatoner 66 to finish off on there. All we'll need the workshop for is to make sure the power's still doing what it was on the bench power supply, and we'll just go through and have a silly little flick round and see whether anybody is swearing on 19. So it was a situation where we got to the stage we needed to change the bridge rectifier and we needed to change the regulator IC. So I've now got both in stock, and I had the sense to buy 2 of each, even though I never intend doing another one of these. So we got the rectifier out already. I had the sense on this occasion to mark which way it went in, but can I see my mark? I think that's it. But before we solder it in, I'll check back with the video. So it's exactly the same part. Oh no, it's not. It's a 200 volt rated one. Because you know what, if we get the 100 volt one, so this is S2 VB20, if you get the S2 VB10, they're a lot more money. And that's because they're used in, I think they're used in Spectrum computers or Amstrad computers. They're used in one of those home computers in the 80s. And so instead of these, you know, costing a £5, people want 15 quid because they see a more affluent market for them. So I've gone up to a 200 volt one instead of a 100 volt one. You'd expect that to be more money. It would have been at the time, but there you go. So why don't the people fixing the Spectrums put the 200 volt one in? You know what, that hole's not quite opened. And that isn't good because it's an awful print. In fact, one of them's lifted and it's not gone through it. I'll just put it through from this side to make sure it's possible. Yes, it does. So I think we're this way on. And it's pushed right in on these because of the limited space we've got in the power supply. I put a pen mark just there showing that that's the one with the dent. So I'm going to recheck the video before we solder that in. So next thing to do is change the regulator IC. These boards are so awful, I might be better off cutting the leads off and then pulling them out quickly. Yeah, we'll cut the leads off. So I've cut the 2 outer ones off, then that leaves the centre one still with a still connected to the device. That's the best way to put it. I'm not sure that was a good decision because it's been bent over So I've taken the whole thing out. Hopefully we can pluck these out one by one. We won't solder the new one in until it's all mounted back in its position, because you can't judge the exact distance to where it needs to be onto the heatsink, so you don't know what the leg length is until you've actually finished the job. Right, that's right, I just need to make sure that these legs will pass through. Yeah, it will. So I'm going to start reassembling it and you'll see how that progresses. But first of all, I need to look at my video and just make sure that the pen mark, which is quite clearly, I don't know why I need to recheck the video, because obviously that's where it goes, but I'm just paranoid. Right, so back onto this, and I put the board back in. So I've got that bridge rectifier in there, the wires are back on, and I suppose we could try it at this point. Yeah, I think we'll try it at this point, and then we can see we've got the voltage ready for the input to the regulator IC. So I haven't put the regulator IC in because I said before we need to get the legs just so we can mount that on its heatsink and put the legs through at this point. At least that's something which is quite easy to service. So remember, when you plug these in, they're on straight away. And remember also, we've disconnected the power from this radio. Well, I'm sure we have done somewhere. Right, so the radio is now on. Now Mr. Chippy's meter of choice is a more expensive than you think analog multimeter. I think they were £159 at the time. So, I don't know, we're around the 30 watt range, and I'm sure 30 watt is, I said, it's because my test set's 30 watts, so 30 is full scale deflection on there. I'll just pop it up on there in the hope that you can see it. So let's have a look. I'll just change my glasses and I might be able to see myself. So I think this is the input side. It says 20 volts. And of course we can't have anything on the output side because the chip's not in. So if you remember before, what did we have? Something like 3 volts, even when I'd taken the capacitor out. So it just goes to show we've actually got something now. So I'll unplug it. We'll put the regulator IC in. So when you have a DUF capacitor in a power supply like that, is this, and in this case it's just because of a silly little thing, you know, it's got put in the wrong way around. It's very easy for the bridge rectifier to fail. The fuses for the secondary of the transformer, we'll put some heatsink compound on here. It doesn't need any washers or anything because it is bolted to the heatsink, which is the negative. You know, back in the day, Maplin, when Maplins were around, they did little tiny 5 gram things of this, and they were much more convenient, this industrial size one from RS, but there you go. These, I'll just check this is M3. Wrong screwdriver. Yep. So we've got that on, put the wires through, the legs through. Then we can screw that to the heatsink tightly and then solder it. The idea being we're not putting the soldering to any strain. These printed circuit boards are weak enough without adding to their problems. I'm not going to tighten that forever and ever, but that looks tight enough. Just want to splay that very, very slightly so there's no chance of it touching. Solder them up. That's the third leg which was in there. Right, we can switch it back on. Okay, so got all that back together, and I've put the wiring back onto the board from the power supply. The radio's switched off. Remember, that's only the low voltage. The high tension, the mains, straight into the transformer. You've got a secondary fuse, and then you get about, what, 16 volts going into the regulator and 12 coming out. So we're on the 30 watt, I keep saying that because the test set's 30 watt. So we switched on. So our input, 22 volts, our output, spot on the 12 on this meter. So we'll go over to the workshop, but first of all I'll just switch this radio on. And make sure it can, there we go, we're lit up on its own power supply. So all I've got to do now is make sure that we set the power supply, we set the radio transmitter on the bench power supply, and we had it so that it was doing 4 watt output on 12 volts. So theoretically that's 12 volts, we should get 4 watt output. But if not, the very final coil might need very slight adjustment to bring that where it should be. Now we can't use the cameras on the other thing because it's a different format, so I'll carry on using the camcorder. Mains power supply, and it's doing 3.6 watts on that power supply, which is exactly what you'd expect it to be doing. Now we've only got one problem, and of course if you remember back in part 1 when we first looked at the set, we discovered the microphone isn't working. So I've got my walkie-talkie on and testing 1, 2, 3, whereas with our mic, testing 1, 2, 3, 1, 2, 1, 2, testing 1, 2. There we go. So we better open up the mic. We don't normally do mic repairs, but what do you do in this situation? quite a strong construction when compared to others. I'll put the soldering iron on because you never know. But if it's a duff insert, you know, what do we put in? Some random insert that sounds different. So there's the insert. Let's just get a multimeter. Across it. So I'm on ohms. You won't be able to see this because of the camera position, but I'll tell you. You're expecting something like 600. And I've got nothing. Right, if we unsolder the insert, I think we'll cut off the negative one, otherwise we're going to end up having to put more wires on than ideal. So that's the insert removed. It's kind of come away from its kind of carrier. So you never know if there could be a wiring problem. Let's see if we can pull the wires out without breaking anything. You know what? There's a wire off. We are in with a chance. I do not like this knot. That's poor practice. If this is the case, it's the first time in years that I've actually been able to repair a microphone capsule. Right, so now I've done that, let's put the meter across it again, because that could be a false hope. .400 ohms. Right, we live in hope, don't we? Now the trouble is, that tiny little hole in the plastic moulding, we're not going to be able to get the wires back through that. The wires will be put through first and then soldered, so we will open up the hole. you also might look that the grill looks like the microphone's at the top, and when you look inside, the PTT switch is at the top, and only the lower part of that grill actually comes through at all. Just put that back in. And we'll wire it back up. Right, I'll put at least one screw in. Background music's a bit louder than usual today. Probably get a copyright strike for the background music. These are transfers from some reel-to-reel tapes on the background music system, and they were originally done by World Records, which was a record club. They're all original recordings that they commissioned, which some of them are the best I've ever heard. Right, let's plug that in. Test it, 1 2 1 2. Wallow. 1 2 1 2. No audio. 1 2 1 2. Oh, you couldn't make that up, could you? You really couldn't. Back to the trainings my training in the 1970s with General Electronics, and you know, you do the exams, and they put a fault on something, and you've got to find it. Well, I'm thinking in particular of doing when I did the television training course, City and Guilds one, and you know, they come into the thing with a television on with a fault, and you've got to fault find it. But there's only ever one fault. In reality, there's a pile of faults. Right, we're going to key this up, and we're going to find where this break is. 1 2 1 2 1 2. We're not going to find where this break is. I'm going to take this plug apart, because I don't think this is the original plug. Yeah, there's a wire off in the plug, folks. How can that be? There's a wire off in the mic, there's a wire off in the plug. Right, well, what else can fail now? I'll tell you what, we'll plug it in before putting it back in the shell. Way, we've got audio. So we always use the metal plugs on sets requiring 5-pin DINs, but there you go, a bit of a price difference. Like these are pence and those are pounds. Right, back together. Testing 1 2, testing 1 2. Brilliant. Right, we'll flick through the channels. Go back to higher power. 1 Nano, roger. And there you have it. It was talking away when I was messing with the mic before turning the volume down, but there you have it. We've got the B40 back working on its own power supply. Quite a few things to do, as you saw in part 1. But thanks for watching. I thought we'd just do it on the camcorder, otherwise we won't be able to publish this till Tuesday. So we'll do the on the air test on Tuesday. I presume he's at Nottingham.